Hello and welcome to another TOS9300 Electronics YouTube video. Today I'm here to discuss patient leakage current testing, an extremely important electrical safety procedure required for electromedical devices. Electromedical devices, or EMDs, envelop a wide range of instruments used for therapeutic or diagnostic purposes. These include anything from surgical instruments and catheters to imaging equipment and monitoring devices. Medical devices often have active parts inserted into the patient body, and they sometimes come into direct contact with sensitive organs like the heart. This makes already susceptible patients even more vulnerable to electrical hazards such as leakage current, meaning that stringent electrical safety testing is critical. Most electronics follow international guidelines such as IEC 60990 that define the different levels of hazard current and how it reacts to the human body in terms of current intensity, ranging from perception, measured at a few microamps, to electrical burn at several hundred milliamps. These standards are sufficient when applied to regular electronics, but measurements for these standards are conducted using human impedance networks simulating how electricity reacts with human skin, which exhibits a relatively high electrical resistance. Internal body components, such as blood, muscle, and organs, do not share this characteristic and exhibit a much lower resistance to electricity. Some cardiac procedures require electrically conductive catheters to be placed directly onto the patient's heart, where currents as low as 20 microamps, which is not considered dangerous in conventional electronics, have been known to cause problems such as ventricular fibrillation. In order to protect patients from even the smallest traces of leakage current, standards for medical devices such as IEC 60601 define strict requirements for protection against electric shock hazards. These standards include electromedical device-specific safety parameters such as patient leakage current, which can range from 10 microamps to 50 microamps DC, or 10 microamps to 500 microamps AC, depending on the equipment classification. The nature of patient leakage current tests requires cutting-edge measurement instruments capable of detecting extremely small traces of leakage current, as well as terminals that output 110% of the rated voltage of electromedical equipment. Luckily, products such as the TOS9300 Safety Analyzer series by TOS9300 Electronics offer an all-in-one solution capable of not only patient leakage current tests, but come equipped with AC and DC high pot, insulation resistance, and ground bond testing capabilities in a single unit. Conducting a patient leakage current test with the TOS9300 is as simple as setting test conditions, starting the test, and making judgments. In order to make your test settings, press LC from the function menu screen, and then press Patient. From here, you can configure a wide variety of settings, including polarity, upper and lower limits, test time, and measurement ranges. As you can see, the network is already configured as I, which represents IEC 60601-1. Patient current specific settings, such as 110% of the DUT rating, can be accessed by pressing Connection and 110% Out. From here, you can simply switch this setting on to apply 110% of the DUT's rating in either a positive or negative polarity. Another critical feature in patient leakage current tests is the measurement range. You can access this by pressing the measurement button and then pressing Range. You can select your desired range in either peak or RMS measurements, which can detect currents as small as 0.1 microamps. Once you have your test conditions set, and your DUT is connected in the appropriate manner, as mentioned in page 161 of the user's manual, you're ready to conduct your test. All you need to do is make sure that Ready is shown on the display, and then press Start. You can monitor the test progress while it is being conducted until a proper judgment has been made. The TOS9300 will notify if your DUT performed within specifications with a pass judgment, or will give you either an L fail or a U fail if the leakage current went either above or below the upper and lower current limits respectively. Once this test has been completed, you can rest assured that your electromedical device is compliant to the latest patient leakage current standards and is deemed safe in a medical environment. And that's all for today's video. For more information on the TOS9300 or any other TOS9300 products, please click on the link below or contact us at our overseas email. Thank you for watching.